Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm going to talk about bonds, how to evaluate the price of a bond and how to amortize a bond. So let's get to know what are bonds. Bonds are means of borrowing money that is frequently used by the federal government, corporations, states, and municipalities. In this form of borrowing, the lenders or investors, the people or institution who buy the bonds, will receive the coupons for a fixed period of years. At the end of the term, the lenders receive the original amount of the loan back. There are some core types of problems relating to bonds. Determine the price of a bond to earn a given yield rate. Determine the yield rate for a bond selling a given rate. Premium or discount amortization method for bonds. Callable bonds. So now let's learn how to evaluate the price of a bond. If you purchase a 1,000 bond with 8% annual coupons maturing in 10 years, what future payment will you receive? Here, the lender who buy the bond will receive a coupon at the end of each year. And each coupon is 8% of the face amount, which is $80. And at the end of year 10, the lender will receive the par value back, which is $1,000. So the price of the bond is just the present value of the bond, which is the present value of two portions, the 10 coupons and the redemption value. So let's I be the effective rate of interest. The present value of the price of this bond is 80/10 plus 1,000 V to the 10. However, some bonds do not mature at face value but redemption value C. For example, 1100 for this problem. So P is 80 times 810 plus 1100 V to the 10. We replace 1,000 by 1100 because for this problem, the redemption value is C. At the end of year 10, you actually receive $1,100, not just $1,000. There are some terminologies that you need to know to practice on bonds problems. P is the present value of the bond, which is the price of the bond. F is the face value or the par value. C is the redemption value, which is the amount that you receive back at the end of the term. R is the coupon rate, and this coupon rate is computed on the face amount. G is a special coupon rate computed on the redemption value because, as I said, sometimes F and C are not the same. So G is the coupon rate computed on C and R is the coupon rate computed on F. Just make sure it satisfies FR is equal to CJ to guarantee that the coupons still remain the same. N is the number of remaining coupon payments. I is the effective rate of interest payment per period. K is the present value of the redemption value C. Sometimes the problem will not give you the redemption value C directly, but they give you the present value of the redemption value. So make sure you know K is just CV to the end. And there are three basic formulas for bond. The first one is the basic bond price formula. P is the present value of all coupons and the redemption value. All coupons, the present value should be the present value of an annuity with the payment is the coupon. And C times V is the present value of the redemption value, and we also can replace this one by K. FR is the same as CG, so P is CGAN plus C times V to the N. The second formula for bond price is the premium and discount formula. Here, Vn can be rewritten in the terms of An. Vn is V to the n is 1 minus I times An. So this formula turns out to be C plus Fr minus Ci times An. And we also can replace Fr by Cj. So in this formula, P is the price, C is the redemption value. This amount, this quantity Fr minus Ci times An can be either premium or discount depending on whether it's positive or negative. So the premium and discount amount is basically tell you the distance, the difference between the price and the redemption value at the end of the term. And we have one more formula. On the premium and discount, we rewrite V to the n in terms of An. For the Macon formulas, we rewrite An in terms of Vn. So An is 1 minus V to the n over I. And Cv to the n is replaced by K. So the formula turns out to be G over I times C minus K plus K. So this formula is helpful when you are given the redemption value and the present value of the redemption value. Premium and discount. As I said, the premium or discount amount is to measure the difference between the price and the redemption value. Sometimes the amount can be negative, sometimes it's positive. So if that amount is positive, we call it's a premium. If it's negative, we call it discount. So the premium discount formula is ideal for quickly determining whether a bond is sold at premium or discount. Let's recall the formulas for the bond price. P is C plus Cj minus Ci times An. Here Cj is like Fr. So this term Cj minus Ci times An is the difference between the price and the redemption value. If this quantity is positive, we said the bond is sold at premium. Otherwise, we said the bond is sold at discount. So if G is greater than I, the price is the redemption value C plus a positive quantity. So P is greater than C. And the amount of premium is Cg minus Ci times An. Otherwise, if G is less than I, the price of the bond is the redemption value plus a negative quantity. Therefore, P is less than C, and the bond is budget a discount. Ci minus Cj times An is the amount of discount. Let's look at this example and try to figure out if this bond is sold at premium or discount. A $1,000 bond with 8% semi-annual coupons redeemable at $1,050 in 1.5 years, budgeted to yield a nominal annual rate of 6% compounded semi-annually. So the term here is actually is half year, not a year. So at the end of each half year, the lender will receive a coupon of 4% of 1,000, which is $40. And the interest also compounded at the end of each half year at 3%. So to determine if this bond is sold at premium or discount, we find G, because we need to verify the relation between G and I. So G here is Fr over C. Remember, Fr is equal to Cj. They both measure for the coupons. So G is 1,000 times 0.04 over 1,050, which is 0.038. And this G, the special coupon rate, is greater than I, the interest compounded at the end of each half year, because I here is 0.003. So the bond was purchased at premium, and the premium amount is CJ minus CI times AN, which is 24.04. And the price is P is equal to 48.3 at 3% plus 1050 V to the 3. The price is 174.04. And this price is basically just the redemption value plus the premium. So when you need to determine if the bond is sold at premium or discount, you can either calculate G and compare with I, or you can find the price of the bond and compare with the redemption value. If the price is greater than the redemption value, is sold at premium. If the price is less than the redemption value, is sold at discount. Now let's learn how to amortize a bond. It's just similar to a loan, but for the bond, there's some terminology that replace for the terminology in loan amortization method. Let's consider a premium bond, a $1,000 bond with 8% semi-annual coupons, redeemable at 10, 50, and 1.5 years, purchased to yield a nominal annual rate of 6% compounded semi-annually. So here's the table of amortization schedule. There are a couple of things that difference from the amortization schedule for a loan. In the loan, this one is the outstanding balance. So in amortization schedule for the bond, the book value replaces the outstanding balance. The amount of amortization of premium replaces the principal paid, and the coupon replaces the payment. And if you observe the table, you would see that the book value at time 0 is just the price of the bond, which is 1,074.04. Coupon, here 8% semi-annual coupon rate redeemable twice a year. So at the end of each half year, the lender who buys the bond will receive 4% of the face amount, which is $40. The interest earned is just the interest rate times with the book value, the previous book value. So the interest earned here is 0.03 times 1074.04 is 0.03, not 0.06, because this is nominal annual rate, 6% compounded semi-annually. So it's half year, you receive 3% interest. So the interest earned is 32.22, and you see that the coupon here is greater than 32.22. The amount of amortization of premium is the coupon subtract the interest rate, and the book value is the old book value subtract the premium amount. So you can see that the book value is written down because it starts with 1074, goes down to 1050. The amount of premium total is 24.04, which is exactly the difference between the price and the redemption value. Here, the third value in the book value column is the price, and the last number is the redemption value. So for premium bond, the book value is written down over time. Interest earned is IT is equal to I times BT minus 1. Amortization of premium is the coupon subtract IT. The book value is just you subtract the amount of premium from the last book value. For a discount bond, let's say a $1,000 bond with 8% semi-annual coupons redeemable at 10.50 in 1.5 years, purchased to yield a nominal annual rate of 10%. So this is 10%, not 6%, compounded semi-annually. Let's make the schedule, amortization schedule. Here the present value of this bond is 1,015.96. We have learned how to calculate the price of the bond, so I skip this step. Here the price of the bond at time 0 is 1,015.96. Coupon is $40 at the end of each half year. Interest earned, here 5% is interest for each half year. So the interest earned is 0.05 times the last book value, which is 1,015.96, and you got 50.80. Here you see that in the amortization schedule for a discount bond, the interest earned is greater than the coupon. Interest earned greater than the coupon. So for the discount bond, the book value is written up because the price of the bond is less than the redemption value. You see it? So from the price goes up to the redemption value, we going up, we write up. So that's everything about this lesson. I have one more video about a bond. I will talk about how to evaluate the price of the bond between coupon dates, and how to work with callable bonds. So now let's do some practice. Tristan purchased a 5-year bond with a par value of $1,000, 4.2% semi-annual coupons, and redeemable at $913. If Tristan's yield rate is 4.5% convertible semi-annually, determine whether the bond is sold at a premium or discount, and compute the amount of that either premium or discount. So here to approach this problem, we have two approaches. Either you compute G and then U dash to phi, and then you compare with I to see if it's premium or discount, and then just follow the formula of premium and discount amount. The second approach is you find the price of this bond, and then compare with the redemption value, which is 913. So the difference is the amount of either premium or discount. So let's look at the first solution. G is FR over C. Here 4.2% semi-annual coupon rate. So at the end of each half year, the lender who buys the bond will receive 2.1% of the face amount. So G is 2.3%, and 2.3% is greater than I because I here 2.25%. 4.5% convertible semi-annually, that means at the end of each half year, the lender will earn 2.25% interest rate. So this bond is premium, and the amount of premium is just FR minus CI times AN at 2.25%. Here 5 years, but because the interest is compounded semi-annually, so the number of term is actually 10. So the premium is 4.056. An alternative way is we find the price of the bond. So the price of the bond is just the combination of the present value of all coupons and the present value of the redemption value. So the price is 917.056, which is greater than 913. So the premium here is 4.056. If you make this amortization schedule, the book value should be written down because we start with 917 and write down to 913. So it should be written down. Second question. A 10-year 1,000 par value bond pays 8% coupons semi-annually. The bond is priced at 1182 to yield an annual nominal rate of 6% convertible semi-annually. Calculate the redemption value of the bond. Just follow the formulas. 1182 is the price of the bond. 40 is the coupon, because 8% coupon semi-annually, that means at the end of each half year, the lender will receive 4% of the face amount, which is 40. And let's say C is the unknown redemption value. So the present value of the redemption value is C times V to the 20. Here a 10-year bond, but because the interest is compounded semi-annually and the coupon is and the lender receive coupon semi-annually, so we use each half year as a term. So we have 20 terms. So C here is 1060. Problem number 3. Trump buys $1,000 bond with 5.9% annual coupons maturing at 1110. Find Trump purchase price if the effective annual yield rate is 8% and the present value of the redemption value is 1,027.78. So in this question, they give you the present value of the redemption value, not the redemption value. The present value of the redemption value, that means K, not C. So here the present value of the redemption value is the redemption value times V to the N. And solve this equation, we have N is 1. So this bond is actually sold with 1 year term. So now we calculate the price. P is coupon times A1 at 8% plus the present value of the redemption value, which is K. And the answer is 1,082.407. Problem number 4. A 20-year bond with a par value of 100 with annual coupons at 3.5% is purchased to yield an effective annual rate of interest of 4% if held to maturity. The book value of the bond at any time is the present value of all remaining payments using the 4% rate. 10 years later, just after a coupon payment, the bond is sold to yield the new purchaser a 5% effective annual rate of interest if held to maturity. What is the excess of the book value over the second sale price? So that means we want to find the difference of the book value at time 10. So at time 10, we have finished 10 coupons. We still have 10 ahead coupons. So using the old rate, the book value at time 10 is just the present value of the last 10 coupons at 4% interest rate. So using 3.5 is the coupon, 10 is the number of remaining coupons, 4 is the interest rate, 100 is the redemption value because it's redeemed, it's held to maturity. That means it's redeemed at par. So the answer, the price, the book value at time 10 of this bond using 4% interest is 95.94. Now using new rate, the book value at time 10 after the 10 coupon, if we start using 5% interest rate, is 88.41. So the difference, the excess of the book value over the second sale price is just 7.53. So this is the final answer. So the book value can be just like amortization method. We have retrospective and prospective method. So for this one, we look forward to the remaining payments, the remaining coupons. Problem number 5. Let I be the yield rate of a bond. C is the redemption value of the bond. G be the modified coupon rate. That means the special coupon rate. P is the price of the bond. K is the present value of C at the yield rate I. Simplify the following expression. IP minus GC over I minus G. Here the question mentioned K, so I am going to use try to derive this formula in terms of K. So remember, P can be written in terms of C and K, right? So here P is C plus C times G minus I times AN. Because the reason why I use all C here is, you see at the bottom we have I minus G. At the top we have I minus G. I times something minus G times something. So if I can modify this one as I times C plus an amount, then I can simplify some terms, right? So here P can be rewritten into C plus C times G minus I times AN. Now I substitute P into the expression. I have the first two terms is the same as IP. So this IC plus IC times G minus IAN, and the last term is GC. Now we group IC and GC together, so I have I minus G times C. And this term becomes G minus I times C times 1 minus V to N, because AN is 1 minus V to N over I with I cancel. So this second term turns to be G times C times G minus I times 1 minus V to the N. Now the first term will be cancel out with the denominator when you got C, and this term also be cancelled, so it's C minus C times 1 minus V to the N, and it's become C times V to the N, and this is just the present value of C, which is K. So the final answer is K. Six, Horace buys 1,000 bond with 4.2% semi-annual coupons maturing in 15 years and redeemable at 1030. If the purchase price is 902.76, find the effective annual yield rate on his investment. Solution: let I be the nominal rate of interest compounded semi-annually. You have the price of the bond is 902.76. This is equal to the present value of the coupons plus the present value of the redemption value. 21 is the coupon at the end of each half year using 4.2% semi-annual coupon rate. So let's say I is the nominal rate of interest compounded semi-annually. So we have 21 times 830. I half is the present value of the coupons, and 1030 times V to the 30 at the rate I over 2 is the present value of the redemption value. So I over 2 is 2.64%. Hence, the annual effective interest rate is I prime, which is equal to 1.0264 squared minus 1, which is 0.0535. So the effective annual yield rate is 5.35%. Since the question asks you for the effective annual yield rate, not the nominal rate of interest compounded semi-annually, so you couldn't stop at I. You should go furthermore to find I prime. So now we go to problem number 7. Megan purchased a 3-year bond with a par value of 100, 3% annual coupons redeemable at 110. The annual effective yield rate is 6%. Find the amount of accumulation of discount or the write-up in the first year. The general idea for this problem is you need to find the price, the book value of time 0, to compute the interest over the first year and find the difference between the interest over the first year and the coupon. Because this question asks for the amount of discount over the first year. So the price of this bond, or the book value of time 0, is 3A3 at 6% plus 110 V cubed. So the price is 100.377. The interest earned during the first year is 0.06 times the price. You got 6.02 for interest earned. So the amount of discount in the first year is the coupon subtract I1. You got 3.02. Problem number 8. A bond with 100 par value has 5.25% annual coupons and is due to mature at the end of 16 years. The bond will be redeemed at maturity for an amount equal to its par value less a service charge. The service charge is equal to 25% of the excess, if any, of the par value over the purchase price. A prospective purchaser offers a price that will produce a yield equivalent to a 7% annual effective interest rate, taken into account the deduction of the service charge. Find this bond price. So here the question gives you F, R, N, but they didn't really give you the redemption value. They said if any, the service charge, the redemption value depends on the service charge. The service charge is 25% of the excess, if any. So that means sometimes it exists, sometimes it doesn't exist. So we have to separate this problem into two cases. The first case, if the par value is over the purchase price. So that means the redemption value is deducted by a service charge. So the service charge here 0.25 times the difference between the price and the par value. And since the par value is over the price, so we have 0.25 times 100 minus P. So the redemption value is 100 subtract the service charge and derive it into 75 plus 0.25P. Now we find the price of the bond. So the price of the bond is the present value of all coupons. Is coupon $5.25. 75 and 0.25P is received at the end of 16 years. So plus 75V to the 16 plus 0.25P times V to the 16. And we solve this equation for P. So P is 5.25 A16 at 7% plus 75V to the 16 over 1 minus 0.25V to the 16, and the answer is 81.94. Consider the second case. If the par value 100 is not over the price, that means 100 is less than P. So P is so if the par value less than the price, that means the redemption value is exactly 100, no service charge. So the P value, the present value is 5.25 A16 at 7% plus 100 times V to the 16, which is 83.47. However, this price is less than 100, which is contradict to the assumption of K2. So K2 is not possible. So we can conclude that the price of this bond is 81.94. Thank you so much for watching. That's all for today. So in the next video, I'm gonna finish the bond. I have a couple more things to talk about bond. How to evaluate the price of the bond between the coupon days, how to evaluate a callable bond. So see you next time. Bye.